Hello, I'm going to go ahead and do several literal equations here as examples in a video and explain how to do them. This is the worksheet we did in class, so I'm just going to copy the problems as we go. Okay, so this is the first one, and here we are solving for g. So the first thing I notice is that there's only one g, so I'm going to try to get rid of everything that's around it. So first I'm going to add the a, and then probably the 2, and then the n, or in which that doesn't matter the order as much of those last two. Okay, so first I'm going to add a on both sides. So I'm going to do plus a, and this becomes 1/2 gn. The a disappears, equals 2a. Then some of you look at this as a 1/2 multiplying. I see it as a 2 dividing, and I think it's easier. So I'm going to multiply both sides by 2. When I multiply both sides by 2, here the 1/2 disappears, and here I get 4a. And then lastly, I'm going to divide by n on both sides, and then the g is all by itself, equals 4a over n. Okay. Number 2 says 2x minus 6y equals 4, and here we're solving for y. Okay, so again, the first thing I do is I look at the y and I see what's around. There's only one y. So I do this, and I know that first I'm going to have to get rid of the 2x, and then the negative 6. It looks like I'll be done in 2 steps. So the first thing, I'm going to subtract 2x on both sides. So negative 6y equals 4 minus 2x. And then I'm going to divide by negative 6 on both sides. So y equals 4 minus 2x all over negative 6. And now there's 2 ways to simplify this answer. The first one is necessary, the second one is optional. In the same way that we never want a 4/6 as an answer because it can be simplified. That's a fraction that can be simplified. The same thing happens here, except we have 3 numbers. So here we're looking for, is there any number that goes into 4, 2, and 6? And the answer is yes, 2. So that means that we can divide everything by 2. So this can become a 2 minus x. So 4 divided by 2, 2x divided by 2, and then negative 6 divided by 2. And that could be an answer, and that's perfectly valid. Maybe I'll stop here, otherwise it's more confusing. Let's just leave it as an answer. Good enough. Yeah, actually I want to say, and if you wanted to, you can multiply top and bottom by negative 1. So I changed the sign of everything. I also changed the order. This relate, I could write negative 2 plus x, but it's just prettier, one less sign if I also change the order. So you can choose which one do you think is simpler. And if you like the one more and the one on the right more, I think that's a good enough reason to do it that way. But anyway, any of the 2. Okay, moving on. Question 3. Question 3, we get k equals, and in this case we're solving this for w. Okay, so again, the first thing I do is look here. There's only one w, and then there's a plus 2, and then a m. So the first thing I'm going to do is I'm going to get rid of the m by dividing by m both sides, and then I'll subtract 2. Again, some of you like distributing here. I think that eventually you're going to divide by m at the end, so I think it's better to just divide by m now. So this becomes k over m equals w plus 2, and then I just need to subtract 2. And I'm going to change the order. I'm going to put w equals on this side, but you can put it on the other side. Equals k over m minus 2. The important thing is to understand that the minus 2, the 2 subtracts from the whole fraction, not just from the top or from the bottom, but the whole fraction, because we're always doing things to whole side of equations. Number 4. On this one, we're solving for p. So in this case, again, I look at the equation, there's only one b, this is what's closest and then that. So I think I'm going to first add k on both sides. Add k, I said. And then I'm going to divide by k. And then I get b equals a plus k over k. I like that answer. Some of you might simplify this further. It's fine either way. It's debatable which one is simpler, but if you want to do this, because k over k is 1, that's also okay. Either one works. Sometimes there are some simplifications that are clear, and some other ones are debatable which one is more simple. So, okay, so 5g minus p over p equals 1, and we are solving for p. So whenever we have fractions, I think the easiest thing is to first get rid of the fractions. In this case, I'm going to multiply by p both sides. And then on the left-hand side, the p over p disappears, so I get g minus p equals p. And the next thing, I want to move all the p's to one side, so I'm going to add p on both sides. When I add p on the left-hand side, the p's disappear. When I add p on the right-hand side, p plus p equals 2p. And then the last step, solving for p, is going to be just divide both sides by 2. So in this case, p equals j over 2. Okay, next, moving on. Question 6. dc plus a equals c minus dc. And here we're solving for d. Again, the first thing I do is inspect the equation to see how many variables I find. And in this case, actually, d appears twice. So my strategy is going to be to move all the d's to one side of the equation. So probably I'm going to move this to this side by adding dc, and then I'm going to move what doesn't have a d to that side by subtracting a. I can do all in one step, or for clarity right now, I'm going to do it in 2 steps. So first, I'm going to add dc on both sides, and then, so I get dc plus dc is going to be 2 dc plus a equals c. And now I'm going to subtract the a, so I get the, and now all of these are multiplied together. We could write CD instead of DC or 2. They all multiplied together. The important thing to notice is that if our variable is the D, what I can do is I can divide by 2C. If you need to do it in 2 steps, and first divide by 2 and then by C, that's okay. I'm going to do it all in one step where I'm going to divide by both of them. So in this case, I'm going to get D equals C minus A divided by 2C. And that's it. Number 7. By the way, while I copy this, I'll say that in some of these equations, there's different ways of doing these equations. There's not only one way. Hopefully you're getting the, if you're not, and actually there's different answers, equivalent answers. The answer should be equivalent and look very similar, if not the same. But there are different ways of doing it. So my way is not the only way. Right now, here, for example, you could add those two together and whatever two, but what I'm going to start by doing is I'm going to multiply everything by z. I like getting rid of denominators first. So I'm going to multiply both sides by z. But what that means is multiplying this by z, this by z, and this by, every term has to be multiplied by z. Just, if you think about it, it would be like multiplying this by z with a parenthesis, so I do have to distribute. That's why it multiplies everything. So what's going to happen is that the z actually disappears from here, and it disappears from here, and it appears here. Sorry, what am I solving for here? I didn't write that down, did I? I'm solving for x. Okay. So the next thing I'm going to do is I'm going to combine like terms to simplify the left-hand side a little bit. So this is going to be 2x minus 2y equals 4xz. And now if you look at this, you'll see, I mean, I didn't do this with this one, the inspecting the equation, but here there is an x here, and an x here, and an x here. What I want is to bring them all together. In this case now, after my little simplification, I still have two x's there. I wanted to bring them all to one side. I could bring them to this side, but then I'm going to have to move that the other way. So I think it makes more sense to directly move this to this side. How? By subtracting 2x from both sides. If I subtract 2x, I'm going to get negative 2y equals 4xz minus 2x. And this is where people have a little bit harder time. I hope you can see, well, maybe I'll do it first and then we can talk about it. What I'm going to do here is I'm going to factor out an x. X 4z minus 2. Factoring is anti-distributing. I see that there's an x here, and I see that there's an x here, and I say, what would it look like if I took that x out? What would I have to multiply? And hopefully you can see that if I distribute this, I get what's above there. I get the 4xz minus 2x. So factoring is anti-distributing. I'm getting the x out and then writing in this parenthesis what I get from dividing this by x, because the x is now on the outside, and what I get from dividing this by x, because the x is now on the outside. And that's how you find that. And once we've done this factoring, there's only one x. Now I can divide both sides by this 4z minus 2, but that whole parenthesis, that I've just treated as one unit, one block. So then my x is going to be equal to 4z minus 2. Oh, sorry, that's going to go in the denominator. My x is going to be equal to negative 2y divided by 4z minus 2. And this is not so different from the problem we did before, where there were two simplification possibles, one that you have to, and one that's more optional. So one is simplifying. All those numbers are divisible by 2. So I'm going to divide the top by 2, and then divide of each of the terms on the bottom by 2. And then this last simplification, it's optional, but I think it looks better. To get rid of that negative, I'm going to multiply the top by negative 1, and multiply the bottom by negative 1. That's going to give me this. What I'm going to do is change the order, because I think it looks much cleaner to have the positive minus the negative, instead of a negative plus something. So that would be the answer. If you want to stop here, that's perfectly fine. I like it more that way. Okay. Moving on to number 8. By the way that I'm doing this work, I hope you can serve as a model of how I would like you to do the work on your paper. You see how I'm copying the questions and showing all the steps and doing all the work. This is how I'd like you to do this work. Okay, so in this case, we are solving this for C. And this is one where I can see there's a C here and a C here. So probably I'm going to have to distribute this and maybe get rid of that 2 before I can move all the C's to one side. So that's what I'm going to do. Actually, since I'm going to distribute this and then distribute these 2, I think it's worth first multiplying by 2. First getting rid of them. Again, if you do it the other way, that's fine too. But the first thing I'm going to do is multiply both sides by 2. So in this case, the 2 becomes a 4, and that's it. And now I'm going to distribute. C plus 1 equals 4x minus 8c. And now I'm going to move all the c's to one side, so I'm going to add 8c. So plus 8c, this is going to give me 9c plus 1 equals 4x. And then I'm going to subtract 1. 9c equals 4x minus 1. And then divide by 9. Both sides. So c equals 4x minus 1 over 9. There you go. And that was 8, so number 9. K plus r minus 1 over 2r. And we're solving this for k. Again, upon inspection here, you see there's a k here and a k here. There's fractions. So my strategy with fractions is always multiplying by the least common multiple. So in this case, 2r. So I'm going to multiply everything by 2r. When I multiply this side by 2r, the 2r is going to disappear. So I'm going to be left with the numerator only. And when I multiply this by 2r, the 2 disappears, but I still have an r. So I have to multiply the top by r. And let's do it in 2 steps. First, I'm going to leave it like this, so it's really clear that the r has to multiply everything. So next, I'm going to distribute. And now, as I solve for k, I still see, again, that I have k here and here. So probably I want all of those in one side. So I'm going to subtract rk. You could be adding k also, maybe that's easier, but it's fine. So k minus rk plus r minus 1 equals negative r. And then I want to get rid of this part, so I'm going to subtract r and add 1 to both sides. So this is going to be 1 minus 2r, because I have this minus r. Okay, and this is the part where if we were dealing with numbers instead of with variables, this would be combining like terms. So here what we're going to do is we are going to factor out the k. The k multiplies a 1 minus r. If you don't believe me, again, distribute. What I'm doing is anti-distributing. But if I multiply this, I would get k minus rk. That's how I know that I did that right. And that's called factoring. And once I factored, I can, oops, I didn't say that. Here I factor. And here I'm going to divide by that parenthesis so that the k is by itself. And that would be the answer. And then the last problem, number 10. We're solving this for E. E is in the denominator, so at some point I'm going to have to do the reciprocal, but I'm going to do that once that it's by itself on one side of the equation. So the first thing I'm going to do is I'm going to move this to the other side. So what I'm going to do is I'm going to subtract 1 over m and add, or another way of doing this, actually, I'll follow the method. This is one way to do it with fractions, but also what you can do is what I said before. I like getting rid of denominators. So something we can do is we can multiply both sides by m, e, and w. So And I think this is going to be simplify things a lot because then we won't have fractions. So when I multiply this by m, e, and w, I'm left with EW because the m cancel each other out. When I multiply this by MEU, the e's cancel out, and I'm left with MW. And when I multiply this by MEW, I'm left with ME. And then when I multiply the right-hand side by whatever, since I started with 0, I'm left with 0. This is one way of doing this. Actually, there's many different ways of doing this one, but I hope this makes sense. So now I have, again, inspecting my equation, I see there's an e here and an e here. There's no e's here, so the next thing I'm going to do is I'm going to move this to the other side by subtracting. So I'm going to subtract MW. And then this is where I have to factor. In order, what I would like to do is to combine like terms, but that's here is called factoring. When we can, with numbers, this would be combining like terms. So if we have like 3w minus 2w, will be like doing 3 minus 2. Here, what we're going to be doing is saying, I'm going to get the e out of that space. I'm going to factor out the e, and then this is what I will have to multiply that, the anti-distributing. Because again, if you don't believe me, distribute and you'll be getting that. And then lastly, I'm going to divide by the parentheses to get e by itself. So e is going to be equal to negative mw divided by w minus m. And that could be your answer, or like you've seen me now do multiple times in this video, I'm going to multiply everything by -1 because I think that looks a little bit neater. And that would be your final e equals that. I hope you found this video helpful. Let me know if you need anything.